to mathematics classes. SN Mathematics, Circles Part 3. Today we are going to discuss circles and quadrilateral. In other words, cyclic quadrilateral. If all four vertices of a quadrilateral lie on a circle, then the quadrilateral is called cyclic quadrilateral. And in cyclic quadrilateral, opposite angles are supplementary. In this figure, angle A plus angle C is 180 degree and angle B plus angle D is 180 degree. In converse, if opposite angles of a quadrilateral are supplementary, then we can draw a circle passing through all four vertices. If one vertex of a quadrilateral lie outside the circle drawn through other three vertices of the quadrilateral, then sum of the angle at this vertex with the opposite vertex is always less than 180 degree. That is, in this figure, angle B plus angle D is less than 180 degree. If the fourth vertex lie inside the circle, then sum of the angle at this vertex with the opposite vertex is always more than 180 degree. That is, in the figure, angle B plus angle D greater than 180 degree. Show that an isosceles trapezium is cyclic quadrilateral. That is, we have to show that sum of the opposite angles of an isosceles trapezium is 180 degree. In the figure, ABCD is an isosceles trapezium. We know that the base angles of an isosceles trapezium are equal. That is, in the figure, angle A and angle B are equal. Therefore, angle A equal to angle B. Since ABCD is trapezium, then one pair of opposite sides are parallel. That is, AB parallel to CD. Therefore, angle A and angle D are supplementary. That is, angle A plus angle D equal to 180 degree. Also, A equal to B, therefore it becomes angle B plus angle D equal to 180 degree. In the figure, B and D are one pair of opposite angles. That is, opposite angles are supplementary. Therefore, ABCD is cyclic. Calculate all angles of quadrilateral ABCD in the figure. Here, angle ABD equal to angle ACD. Angle ABD and angle ACD are equal. Why? Angles in the same segment, that's equal to 30 degree. Since this angle equal to 30 degree, then we can find angle B. What about angle B? Yes. What is it? 30 plus 45, that's equal to 75 degree. Since angle B is 75 degree, then very easily we can find angle D. B and D are one pair of opposite angles of cyclic quadrilateral. Therefore, angle D equal to 180 minus 75, that is 105 degree, 105 degree. Now we find that angle D equal to 105 degree. One of the portion in D is 50 degree. So the remaining portion is 105 minus 50, that is 55 degree. That is, angle BDA equal to 55 degree. Angle BDA and angle BCA, these two angles What are the angles? Angle BCA and angle BDA are angles in same segment. So they are equal and each equal to 55 degree. That is, this angle equal to 55 degree. Then very easily we can find out angle C. What about angle C? C equal to 55 plus 30, that's equal to 85 degree. Since angle C is 85 degree, then we can find angle A. How to find angle A? Angle A equal to 180 minus 85. That's equal to 95. Therefore, angles in quadrilateral ABCD are 95 degree. Angle B equal to 75 degree. Angle C equal to 85 degree. And angle D equal to 105 degree. These are the angles of quadrilateral ABCD. We move to next question. Prove that any outer angle of a cyclic quadrilateral is equal to the inner angle at opposite vertex. It is very simple proof. That is, we have to prove angle CBE equal to angle D. That is, angle D and angle CBE are equal. For this, we take angle CBE equal to x. That is, let angle CBE equal to x. Then what about the angle ABC? What's the angle ABC? That's equal to 180 minus x. How you got this? These two angles are linear pairs. So, angle ABC equal to 180 minus x. This angle equal to 180 minus x. Then what about angle ABC and angle D? These two angles are opposite angles of cyclic quadrilateral. We know that opposite angles of a cyclic quadrilateral are supplementary. So angle D can be written as 180 minus angle ABC, that is 180 minus x. On simplifying, 180 minus 180 plus x, plus 180 and minus 180 get cancelled, then angle D equal to x. If angle CBE equal to x, then angle D equal to x. Therefore, angle CBE equal to angle D. Hence the result. We move to next question. In the picture, bisectors of adjacent angles of a quadrilateral ABCD intersect at P, Q, R and S. Prove that PQRS is cyclic quadrilateral. To prove PQRS is cyclic quadrilateral, it is enough to show that opposite angles are supplementary. That is, angle P plus angle R equal to 180 degree and angle S plus angle Q equal to 180 degree. That is, we have to prove from this figure. Since the line AS is the bisector of angle A, if we take angle A, the angle at the vertex A is taken as A, so this small portion is half of angle A. So we can take the angle DAS as A by 2. Similarly, angle ADS as D by 2. That is, in triangle ASD. See the triangle ASD. Angle DAS equal to A by 2. We have already discussed this. Angle ADS equal to D by 2. Therefore, the third angle ASD, that's equal to 180 minus a by 2 plus d by 2. Sum of the angles in a triangle is 180 degree. Therefore, angle PSR and angle ASD are one pair of vertically opposite angles. Also, we know that vertically opposite angles are equal. Therefore, angle PSR equal to angle ASD equal to 180 minus of a by 2 plus d by 2. Similarly, in triangle CBQ, this triangle, angle CBQ equal to b by 2, angle BCQ equal to c by 2. Therefore, the third angle, that is angle BQC is 180 minus of c by 2 plus b by 2. Also, angle PQR and angle BQC are equal, vertically opposite angles. Therefore, angle PQR is also 180 minus b by 2 plus c by 2. Therefore, sum of the opposite angles, that is angle PSR plus angle PQR, that's equal to 180 minus of a by 2 plus d by 2 plus 180 minus of b by 2 plus c by 2. On simplifying, 180 plus 180 is 360. So 360 minus of a by 2 plus b by 2 plus b by 2 plus c by 2. Here all the denominators are same. So we can find the sum of numerator and put denominator as 2. That is the numerator a plus b plus c plus d all divided by 2. Here a, b, c are angles of a quadrilateral. It is already learned that sum of the angles in a quadrilateral is 360 degree. Therefore, a plus b plus c plus d is 360 by 2, that is 180. Then the answer becomes 360 minus 180, that is equal to 180. That is, sum of the opposite angles are supplementary. If opposite angles are supplementary, then the quadrilateral is cyclic. Therefore, PQRS is a cyclic quadrilateral. Hence the result. We move to next question. In the picture, PQR are marked on the sides BC, CA and AB of triangle ABC. Circumcircles of triangle AQR and BRP are drawn. M is a point where these circles intersect. Prove that circumcircle of triangle CPQ also passes through M. The picture is given. There are already two triangles and its circumcircle is drawn. The circumcircle of triangle PRB and triangle AQR pass through M. Another triangle is triangle CPQ. We have to prove the circumcircle of triangle CPQ is also pass through M. For this, first we join M to Q, P and R. Now we got a quadrilateral CPMQ. We have to prove this quadrilateral CPMQ is cyclic quadrilateral. That is, it is enough to show that the opposite angles of this quadrilateral is supplementary. First we consider the quadrilateral ARMQ. What type of the quadrilateral is ARMQ? The circle which pass through all the vertices of this quadrilateral. So the quadrilateral is cyclic quadrilateral. In cyclic quadrilateral, opposite angles are supplementary. Sum of the opposite angles is 180 degree. So the angle QMR, that's equal to 180 minus A. That is the first point. Consider the cyclic quadrilateral ARMQ. Angle QMR equal to 180 minus A. The another cyclic quadrilateral is PMRB. In cyclic quadrilateral PMRB, angle PMR, which is equal to 180 minus B. That is the second point. In cyclic quadrilateral PMRB, angle PMR is or equal to 180 minus B. In the figure, there are three angles around the point M. Among these, two of the angles are 180 minus A and 180 minus B. So the resting angle or third angle, that is angle PMQ, is 360 minus 180 minus A plus 180 minus B. On simplifying, PMQ equal to A plus B. In the quadrilateral PCQM, can you see that quadrilateral PCQM in the figure? Yes. The opposite angles are angle PMQ and angle C. First we find the sum of the opposite angles, that is angle PMQ plus angle C, which is angle PMQ is A plus B plus C. Here ABC are the angles of triangle ABC. We know that sum of the angles of a triangle is 180 degree. Therefore, A plus B plus C equal to 180 degree. That is, the opposite angles of this quadrilateral PCQM is supplementary. If opposite angles are supplementary, then the quadrilateral is cyclic. That is, we can draw a circle which pass through all the four vertices P, C, Q and M. Therefore, the circumcircle of triangle CPQ passes through M. Hence the result. We move to next session, two chords or intersecting chords. We know that any two diameters of a circle intersect at the center. Then the length of four pieces are equal. That is, we learnt if diameters are intersecting, then the length of four pieces are equal. Instead, for diameter, if we consider two chords in a circle, if they intersect within the circle, what's the relation connecting the length of four pieces? That's the next session we are going to discuss. For this, we consider a circle and two intersecting chords are AB and CD. The chords intersect at P. We have to find out the relation connecting the length PA, PB, PC and PD. How is these lengths are related? For this, we join AC and BD. Now we got two triangles, namely triangle PAC and PBD. In these two triangles, we know that angle A and angle D are equal. Angle A equal to angle D, angles in the same segment. Similarly, angle C and angle B are also angles in same segments. Therefore, angle C equal to angle B. That is, all angles of these two triangles are equal. It means that its sides are proportional. Corresponding sides are proportional. That is, PA by PC equal to PD by PB. Take cross multiplication. That is, PA into PB equal to PC into PD. That is the relation connecting the length of the chords. That is, if two chords of a circle intersect within the circle, then the product of the parts of two chords are equal. Geometrical interpretation of intersecting chords. If two chords of a circle intersect within the circle, then the rectangle formed by the parts of the same chord have equal area. One of the special case of intersecting chords. Among two chords, one is the diameter and the other chord is perpendicular to diameter, as in the figure. AB is diameter of the circle and CD is perpendicular to the diameter AB. Then PA into PB, which is equal to PC square. What's the relation? PA into PB equal to PC square. That is, the product of the parts into which a diameter of a circle is cut by a perpendicular chord is equal to the square of half the chord. Geometrical interpretation. The area of the rectangle formed of parts into which a diameter of a circle is cut by a perpendicular chord is equal to the area of the square formed by half the chord. Next we move to some constructions. The first question, draw a line segment of length root 15 centimeter. First we find two numbers whose product is 15. What are the numbers? The numbers are 1 into 15 or 3 into 5. If we take the numbers 1 and 15, then we draw a line segment of length 1 plus 15, that is 16, that is the sum. If we take the numbers 3 and 5, then we draw a line segment of length 5 plus 3, that is 8 centimeter. So, it is easy to draw a line segment of length 8 instead for 16. So, we fix the numbers as 3 and 5. We select the numbers 5 and 3. So, first of all, draw a line segment AB of length 8 centimeter and mark a point C such that AC equal to 5 centimeter and BC equal to 3 centimeter. Next we draw the perpendicular bisector of AB. For this, we put the compass at A, take more than half of AB on the compass, then draw two arcs, one above and other one below of AB. At the same radius, same length on compass, from B, we draw another arc which cuts the first one. Then join the point of intersection of these two arcs. Join the point of intersection of the arcs which will give the midpoint of AB. That is the perpendicular bisector. Then using compass, draw a semicircle having diameter AB. Put the compass at midpoint. Take the distance to A on compass. Draw a semicircle which will pass through the points A and B. Draw a perpendicular to AB through C. Either using protractor or by using compass, draw the perpendicular CP, which is the required line segment of length root 15. How to get this root 15? We know that CP square equal to CA into CB. It is already learned in the previous section. Therefore, CP square equal to CA is 5 and CB is 3, that is 15. Therefore, CP equal to root 15. Some more questions. Draw a line segment of length root 11, root 12, root 6 and root 5 centimeter. I left this question to you. Try yourself. Draw a square of area 6 centimeter square. First of all, we find two numbers whose product is 6. What are the numbers? 1 and 6. 1 into 6 equal to 6 or 2 into 3 equal to 6. I take the numbers or select the numbers 1 and 6. Select the numbers 1 and 6. So, draw a line segment AB of length 7 centimeter. How to got 7 centimeter? 6 plus 1. We select the numbers 6 and 1. So, the line segment of length 6 plus 1, 7 centimeter. If we select the numbers 2 and 3, what is the length of the line segment? 2 plus 3, that is 5. Here we select the numbers 6 and 1. So, draw a line segment AB of length 7 centimeter. Mark a point C on it such that AC equal to 6 centimeter and BC equal to 1 centimeter. Next we draw the perpendicular bisector of AB. For this, put the compass at A, take more than half of AB on compass, draw two arcs, one above and one below of AB. At the same distance, put the compass at B, draw two arcs which cuts the first one. Join the point of intersection of arcs, that will give the midpoint of AB. Draw a semicircle having diameter AB, put the compass at midpoint and take the distance to one endpoint on compass, draw the semicircle. Draw a perpendicular to AB through C, which will meet the circle at P. So, the CP is side of required square. So, we take the length CP on compass, mark on extended line of AB. From P also draw an arc. From this point also draw an arc. These adjacent points joined together will form required square. Join adjacent points, that is P, Q, R, C, which is the required square. For the easiness, shade the square. Draw a rectangle of width 5 cm and height 3 cm. Then draw a square of same area. First we draw a rectangle ABCD of given measurement, that is length 5 cm and width 3 cm. Then extend AB through B and BC through C. Mark the length BC, that is width of the rectangle, on the extended line. For the easiness, put the compass at B and take the length BC on compass, smoothly move the compass to extended line and mark the point. It is taken as E. Draw the perpendicular bisector of AE. How to draw the perpendicular bisector? Put the compass at one of the endpoint and take more than half on compass. Draw two arcs, one above and one below the line AE. Then put the compass on other end. Cut these two arcs. Join the point of intersection. Draw a semicircle with AE as diameter. For this, put the compass at midpoint, take the distance to one of the endpoints and draw the semicircle. Then, the point where semicircle meet, that is the extended line where meet the semicircle, is marked as P, which is the required side of the square. That is, BP is the side of the square we have to construct. So, take the distance BP or length BP on compass, complete the square. That is BPQR is the square of area equal to area of the rectangle. Shade the square BPQR, which is the required square whose area is equal to area of given rectangle. Next question. Draw a rectangle of width 5 cm and height 3 cm. Draw a rectangle of same area with width 6 cm. First we draw rectangle ABCD of length 5 cm and width 3 cm. Then extend AB through B such as BE equal to 3 cm and BC through B whereas BG equal to 6 cm. Join A to G and E to G. Now we got a triangle AEG. Next we draw a circle which passes through all the vertices of triangle AE and G. For this, we draw the perpendicular bisector of any two sides of triangle AEG. First draw the perpendicular bisector of AG. For this, put the compass at one end A, take more than half of AG on compass, draw two arcs both sides of AG. At the same distance from G also draw two arcs which intersect each other. Join the points of intersection which will give the perpendicular bisector. Then draw the perpendicular bisector of the side EG. For this, take more than half of EG on compass. From both ends of the segment EG, draw two arcs on either sides of EG and find the point of intersection of these two arcs and join together will give the perpendicular bisector. Join the point of intersection of these two arcs and find the point of intersection of perpendicular bisectors. It is considered as center of the circumcircle and draw the circle which pass through all the vertices of triangle AEG. Find the point of intersection of the circle with the width of the given rectangle, that is taken as H. Extend the side AB through A. Mark the length or width of the required rectangle, that is 6 cm on the extended line. From H also mark same distance. The second side or width of the rectangle is, or height of the rectangle is BH in the figure. So we take BH, the height BH in the compass and mark the arc from here. This point of intersection is one of the vertex of required rectangle. Join the adjacent vertices. The rectangle BADH, the shaded portion is the required